Hello, everyone. Welcome to this stream. You might have heard of Fat Bear Week, which is also going on now. But in addition to that, we have an equally scary one called CVE Week. This week, a whole bunch of unrelated CVEs have been filed across a bunch of open source projects and proprietary ones as well. We're going to start by diving into the first one, which we knew about a few weeks ago. This is a new CVE in cURL. cURL is the most widely used HTTP client in the world. It is a C library that is found in almost everything. Almost any program doing HTTP calls uses cURL somewhere down in the stack. cURL is even present on the Mars rover. It runs on billions of devices. The maintainer of cURL, Daniel Stenberg, announced that he had found the worst security vulnerability in cURL in a long time a few weeks ago. He warned everyone to buckle up. Today, this morning, the CVE was finally released on schedule. This CVE, like most other vulnerabilities in C code, has to do with memory safety. This is a bug in the SOCKS implementation of cURL, which can be used to proxy connections, and it can lead to a heap-based buffer overflow, which can trigger denial of service attacks or even remote code execution, depending on compiler security features and how the exact binary is built. So if you're not using SOCKS, you're probably safe here, but if you are, the vulnerability has to do with connecting to untrusted servers. If your client proxies connections through an untrusted SOCKS server, that SOCKS server can return a response that will trigger a buffer overflow and can do nasty things. The SOCKS protocol in cURL was introduced back in 2000 or 2002, but the vulnerability here was introduced in a minor bug fix just a few years ago in 2020. So it's only been present for a few years. Daniel does a great job commenting here on exactly the root causes of the vulnerability, including the elephant in the room, the memory safety issues. Had cURL been written in a memory safe language, this bug, along with 41% of all other cURL security issues, like Daniel pointed out, wouldn't have happened. Unfortunately, memory safe languages weren't really around in a form that could be used for use cases like cURL when cURL started. So you can't just rewrite cURL overnight. This is a massive program used everywhere with tons and tons of dependencies. The real fix here is to start rewriting parts of it over time in Rust or a different memory safe language. And that's exactly what Daniel is doing. There are a few different plugins for cURL that can be swapped in today if you care about memory safety. One is the Russell's library, which does cryptography in TLS. Instead of OpenSSL, when you compile cURL, you can choose Russell's. We actually have both builds of cURL available inside of Wolfie, our Linux distribution in Chainguard. In addition to Russell's, there's an HTTP parsing client library called Hyper. So the HTTP backend can also be dropped into cURL, which can eliminate memory safety issues when parsing and working with the HTTP protocol. So both of these combined can get you a much more secure cURL. But if you're not happy there, then Daniel says, roll up your sleeves and start helping, because there's plenty more code to rewrite over time gradually, which is the real fix for something like this. Now, on the timeline, Daniel announced this a couple weeks ago and had a little bit of fun building it up toward the actual patch day. This is what's called coordinated disclosure. The other vulnerability I'm going to talk about today did not get a chance to go through coordinated disclosure, and I'll explain why in a minute. But as part of that coordinated disclosure process, Daniel reserved a CVE. That CVE is here, 2023 38545. If you go to the NVD, the National Vulnerability Database, which is the source of truth for all CVE records, it's not actually in here yet. There's a lot of lag in this process sometimes. So if you're relying on the National Vulnerability Database or vulnerability scanners with really tight SLAs, you're probably not going to be happy. None of your scanners are going to know about this vulnerability today, even though he announced it weeks in advance. The scanners rely on data in here to be able to match the programs in your containers or your virtual machines up against the vulnerability database. Until this gets updated, they're probably not going to show up in your scanners. Early this morning when this fix was released, we rolled it out in Chainguard and in Wolfie. We had some automation to automatically submit the PR. Our team merged it to pick up the bump. And then we updated our advisory feed as well 6 hours ago. We actually prepared this in advance because of the coordinated disclosure process. We rebuilt all Chainguard images. So everything built on Chainguard images, if you just update those today, has this fix for cURL. So you don't need to worry about it. It won't show up in your scanners today, and it won't ever because we've already rebuilt and fixed the vulnerability for you. Jumping back to the other big CVE this week, even larger, this one is called Rapid Reset. This is a really, really interesting one because Cloudflare, Google, and a few others detected this vulnerability before anyone knew about it as part of a massive DDoS attack that was going on in the wild. That meant this was a zero-day vulnerability in some form. The vulnerability was exploited before anyone knew about it and before there was a fix available. The other part that really made this vulnerability interesting is that it was a protocol level vulnerability. This is a DDoS attack against anything that implements the HTTP2 server protocol, which is lots and lots of servers on the internet. Because the vulnerability exists in this protocol, anyone that implements that protocol, which is usually just a text document, could be vulnerable to this, barring some minor implementation details. Most web servers are, although not all of them. So the reason this didn't get to go through the coordinated disclosure process is because it was already being exploited actively. When researchers find out a vulnerability has evidence of exploitation in the wild, they usually just rush the disclosure, get it all out there soon so people can start taking steps to protect themselves, even if there aren't full fixes available inside of every program that might be vulnerable. And that's what we're seeing today. This vulnerability jumps straight to the top of the CISA KEV list. The KEV list is a list of the known exploited vulnerabilities in the wild. So at the time of disclosure, you'll be able to see this in the CISA KEV list. So jumping back over to the CVE itself, you can see that here. This is in the CVE website. This list of references, these are just random links that people add to the CVE to help add context and discussion. You can see some Hacker News posts, the Google blog, that Cloudflare blog I was just looking at. But you can also see random links to web servers with fixes or bugs that are getting filed. Stuff like ng HTTP2, HA proxy, Envoy proxy. Anything that implements the HTTP protocol likely has to be fixed. gRPC server implementations. On top of this, the Go programming language, along with many other programming languages, bakes in an HTTP server as part of the language. So if you're using Go and you're using the standard library's HTTP server implementation, which you probably are, you have to pick up that fix by getting a new build of Go. See that here, 1.21.3 or 1.20.10, and recompiling all of your applications with this new version of Go to get those fixes into the standard library. And again, we did that as well here at Chainguard. We started that rebuild of every Go project that we have in our distribution yesterday and cranked through them all, and the latest fix was rolled out today. So every Go program in Chainguard has now been recompiled with a safe version of Go. This CV is also going to be challenging for scanners to catch because it's a protocol level vulnerability. And that data in the vulnerability source that I just showed, those are random unstructured links. It'll probably take a few days or weeks before everyone gets the structured data in place, so scanners actually know which versions of which web servers are vulnerable and which ones are not. If you're worried about this today and you have an internet-facing application, the best way to check into the status is to look in those related links. You'll see builds rolling out today for Node.js and a bunch of other programming languages, and then make sure you update. You can't rely on scanners to tell you about something like this, especially with an exploit in the wild because of the delays in the overall protocol. It's only Wednesday. We're only halfway through CVE week, but I hope that we don't get anything more serious for the rest of the way out. I'll do a quick knock on wood here. With that, if you use Chainguard images, you'll be fine. You don't have to worry about any of these vulnerabilities. Thanks, and hopefully we can all get back to Fat Bear Week.